Hi there. This is a re-recording of a talk I gave earlier this year at Hello World Conference in Porto. The topic of the talk is quality from the start, and I'm going to talk about testing overall and also what you can do to aid your project efforts from a more quality point of view. This talk's target audience was mainly an undergraduate students, but I do think that anyone can take something out of it. Feel free to leave comments with questions or suggestions. I hope you enjoy it. Now, I'll skip the intro part a bit. It's outdated as it is. And for more info about myself, I'd recommend you to pause the video and check out my blog and my social media profiles. The links for these will be available in the video's description. Now, let's start off with a story. Some time ago, my wife was submitting a job application for a position in a public hospital. While she was filling in the data for the application, once it got to her birthday, something was wrong. She filled in the date obeying the format that was mentioned in the input, but no matter what, when she finally tried to submit the form, it failed and said that the date she inserted was an invalid format. She asked for my help to help her out, and being a techie myself, it was one of those fix my printer or the internet is not working moments where I thought I'd quickly be able to save the day and show myself as a master of computers. The thing was that I miserably failed at it. I retried the format she tried that was mentioned in the input field, and the application form still failed. I tried other formats, suspecting that maybe the programmer left the suggestion there, but the suggestion was wrong, and the format wasn't exactly that one. And then we tried once some other browsers we had installed on the machine we were using, and on that machine, nothing seemed to work. Every time the form failed and complained about wrong format on the birth date. I went ahead and even tried to inspect the code. Maybe the validation had a bug, and I could bypass the input validation on the client side. Mind you that the time was running out. It was almost midnight, and the application for that job closed precisely at midnight. Nothing really seemed to work until me and my wife reminded ourselves to use the gaming computer, which some of you know it, of course, had a Windows installation and of course had Internet Explorer. And guess what? It worked. The error of the birth date input that appeared on every browser for some unknown reason didn't happen on Internet Explorer. Now, this sort of problems happens to all of us in different situations, and sometimes in stressful moments. There's also other moments not so stressful, but still funny. One time I decided to report a bug to a favorite pizza online website. It turned out that for a specific combination of ingredients, the user got back an error page with stack trace, and its session became damaged right there and then. At one point, I even recorded my screen and sent the recording until months later they finally fixed that bug. I've had more trouble with pizza websites. Another pizza website, for example, for the first pizza offered me two types of bread. For the second pizza, four types of bread. Do you notice something wrong there? You don't need to understand Portuguese to notice that there's something wrong there, of course. And of course, these problems are always different in terms of severity. At the time, in the project I was working on with my previous employer, problems were much less funny, where any 10-minute failure of a complex system that in turn processed tens of millions of messages per day, it meant that the company would lose money, clients, credibility, and that's very, very bad for business. And the same applies for businesses alike. Even worse, it also applies for software and hardware that is supposed to help you on a medical level, for example, or even worse, hardware and software that has the power of putting your entire nation into big trouble with other nations alike. And in the middle of all this, we're always prone to point fingers at someone. Who is the person to blame for a mistake? Who will pay for mistakes? Someone is always to blame for a failure. Maybe it's the user that is dumb, the tester that didn't magically test everything, or the developer who was sloppy or made a huge mess. Now, hold on for a minute. I'm not entirely sure this is the way to go here, and I'll get back to this point. Have you ever asked yourself, why do we test? In this case, why do we test in software? The best software testers in the world put it simply, but not in an oversimplifying way. We test to verify that something can work. Notice that they're saying can work. They're not saying that it actually works. And the can part is there for some reasons. One of them being the one thing will always fail to control, and that prevents software in this case from working properly. And what is that? Bugs. This is a definition of bug that I like, in this case made by Igor Bugayenko, but quite probably built on top of other definitions made by other people. Bugs are any error, flaw, failure, fault, in our case, in software, that causes it to violate any functional or non-functional requirement. Our innate ability to produce them, to produce bugs, taking into account that we ourselves are faulty, is what also raises the need for testing, for the hunting down efforts to find these bugs. That's why the best testers in the world, like for example James Bach, say in different ways the same message. Testers are headlights of a project. You can be an awesome driver in the most awesome car, but you'll still need headlights to see perils and the road itself in darkness. Software testers do the same with software. They dispel the illusion that the code, for example, any program makes is any good. If you could sum down a tester's main mission, it's that of finding and reporting tons of meaningful and authentic bugs using any means necessary to properly hunt them down. These means can be the tester's intellect, their guts, their always thirsty knowledge, or their always scouting ability, or their ability to use tools or to make tools and programs to aid testing efforts. Now, do you remember the previous who's to blame question? The best answer I find for this question, in my opinion, or the most complete one, I think, more than pointing fingers to an actual someone, is anything, everything between the code we produce and the end user. Now, take a moment to think about this. If for some reason the user interacted with something in an unpredicted way, or the tester didn't find that one nasty bug while hunting for bugs, or the developer failed in the translation of any requirement, there is bound to be something, some deficiency in the way the project is itself designed and the overall architecture of the project was conceived. If a project is badly conceived, for example, and this is more common in the industry than one might think, tons of projects fail for multiple reasons, then there is possibly a lot wrong from the moment we think to the moment we code and test onwards to the instant we ship something to the user. That also allowed for any individual to make a mistake and be the one we rush to blame. The conception and design of projects has a lot more to do with craftsmanship inside projects than individuals we rush to blame. A fellow programmer once put this simply but straight to the point. For programmers actually, and in similar fashion, I think it applies to everyone involved in a software project. We can't change ourselves into perfection, but our craftsmanship attitude, that is something we can change. And that impacts the project's own design in such a way that it can work properly for everyone involved in the project. In a project, your craftsmanship attitude, whether you're a tester or programmer or manager, it'll help define the, so to speak, bed that everyone in the project lies down. At some point, we have to ask ourselves, what can we do to help make a better bed for myself and others impacted? I'll go over a set of advice that I think I can give on this, but before any advice, I would definitely recommend you who are watching to set up disposable time to get to know the tools you use right now in your projects. Tools we use or know how to use make tons of difference in the success of projects. A lot of times when we're at school, we expect teachers, for example, to magically make us masters of the tools they're teaching, be it a Bash terminal, an Excel sheet, or even C++ programming language. Don't expect that. Set yourself up to go the extra mile and learn more about the tools you use. Now, the following advice I'm going to talk about, like other info in this topic, doesn't come from my bare imagination. Credit for the following, for example, goes to a particular blog post about deadly sins that you can make in a software project. This post was made by Igor Bugayenko. And the first thing you have to ask yourself, if you can give yourself the chance to be sloppy in a project. Sloppiness here is referring to the anti-patterns we tend to make a lot of times, and we don't worry about, for example, when we're still undergrad or graduate students. My advice here is no, don't be sloppy, always be skeptical about the code you write or the approaches you follow to solve a particular problem. Try to read and inform yourself of what possible mistakes you might be making. Never take for granted that what you do is perfect. That's a shortcut to the most vicious anti patterns, and you can go through them and recognize them better by learning and informing yourself better. Don't expect a school system or a teacher to magically pour out this knowledge. It comes best when it's made through a personal effort of researching this matter. Second thing you should ask yourself is what is the most appropriate way to keep track of the stuff you do, be it individually or in a team? You should always have a sweet spot in your heart for traceability. Traceability of your work might not seem important during undergraduate or even graduate school, but the difference in the quality of a project, even if it is a school project, is huge when you can measure and trace back your own work and the work of your buddies. Here I have three suggestions. Use tickets, reference them, and don't hit delete. What I mean by using tickets, I don't mean you should wrap yourself around a ticketing tool or maybe like Jira or Target Process or Trello or some of these tools. The tool part here isn't the most crucial or important. The really important is uh, in dividing actually and also finding out the best way to divide a project, a big problem, so to speak, into smaller achievable and deliverable answered problems. Now, any tool is this I think is decent provided you have worked out with your teammates or by yourself the proper milestones and achievables, provided that you had the work of dividing a big problem into smaller chunks. Again, this can be done anywhere, even close to your code like with GitHub or GitLab. You don't need to close yourself to a specific tool. The second suggestion here in this main topic is that you and your colleagues should reference the proper tickets and the pieces of work you produce. Once you start using version control, for example, when you're coding, don't use it like a noob like this. Learn to use it elegantly. For me, as a teacher or a contributor or a fellow programmer or tester, it's way easier to jump in on any branch of the problem if I can trace each piece of work to a milestone or to some objective of a bigger mission. Now, the third suggestion is don't go crazy and delete everything if you reach a blocking point. This happens a lot more than we think about it in projects. Sometimes we just want to go ahead and delete some hours of work from existence in a way we can't recover them. Don't do this. As a teacher, for example, it would be valuable for me to see in a traceable fashion, hey, these guys at some point decided to scrap work, start some parts of that work over, but I can easily see every step they took through history, and every decision and change is linked to something I can read about and understand you. Now, let's let's skip enough about traceability. Let's talk about releasing our work and working in a responsible way. This scenario is one I think any student knows well nowadays of working like crazy, Poor organization of our projects, we left everything to be done near the deadline, and at the end of the line, we deliver a half-baked project to our teacher on the last minute. It's easy to understand this is no proper way to work. Instead, we should have the process of doing stuff defined in such a way that we're helping our future selves. Compare the previous situation with this one. We do some chunk of work, we have a script to package that work, publish it somewhere the teacher can access, and then we repeat this. We might not have everything done by the end of the deadline, but we have several different milestones done in a responsible way, maybe 90% of all of the work that the teacher can evaluate, instead of a crappy and rushed project. My best advice here is for you to make disposable time to learn about this, to learn about ways to do this, using version control and doing proper versioning, and using bots to help you merge and release work. Setting yourself up and your teammates in this manner now will increase your craftsmanship in the industry later, where a lot of times projects that you don't have a lot of decision power are conceived and designed by people who, for example, at school were also underachievers and rushed off big projects. In this case, you have the power to set yourself up to become a strength, moving in the opposite direction in projects. Next thing I'd recommend you to learn how to, in many ways, set yourself up to keep your work and, for example, your code base tidy and clean. There are ways that help keep your code, for example, more or less tidy, for example, with static analysis and other code quality tools. If you don't know what that is, take the programming language you're mostly using now and search of automated code quality checks or good static analysis tools you can set up that will keep telling you about mistakes you might not have even heard of that are prevalent in the code you make. An even bigger but good challenge is, for example, to set these tools to fail your build. So whenever you're trying to compile and build your source code, if there is, for example, a typical code smell, it will be detected and you'll be forced to fix it. And in the meantime, you'll also be learning about this. Another important thing you should consider early on, and definitely not expect for that course that will gently talk about this, how you check your code is logically working well. Now, hold up for a minute. Here, I'll just be very straightforward. Do everything in your power, research, figure out how you can set up a coverage patch, in your project, which in turn, to me as an external reviewer of your project, tells me quite some things. It tells how much of the code base, for example, is covered with these unit checks, typically called unit tests, which means you had to learn about them and create them. You might not have covered your code entirely, but you invested in making it a bare minimum testable. You invested in checking what can be automatically checked, and you might have invested in, while developing, setting up some unit checks to see if logically your code is doing what it should be. It tells me as a reviewer that at the very least you cared. You cared about setting up some coverage library, adding the badge to the README of your project, and that you cared about testing your own code, and in this case, measuring how much of it you're automatically checking. All in all, the badge itself, or even if you told me I have 100% coverage, it's not a guarantee of high quality. But on the other hand, if you're not measuring it, it's always an indicator of maintainability problems in your codebase. Next in the list is a topic we usually don't pay a lot of attention to. How do we explain in words what the stuff we build for a given project does? How anyone can build it? What's the overall picture of it? My advice in this case is very straightforward. Try to develop the habit of writing down clearly everything a potential user would need to know in order for that user to use or build your project. This not only helps others, but also helps for future maintainability of the project. And anyone can easily pick up the project at any point in time. And as a bonus, the more practical stuff you document, the more info you have at ready, for example, when you need to build a report of your work. If you look at this, all of these advice and fight to apply them your own way, you'll start noticing how empowering it is for a school project that you do with colleagues. A project that, for example, anyone can pick up and build on top of. Notice that you're setting yourself up from the start for a lot of fronts that help maintainability. Imagine the difference it would make in creating sort of a more lifelike scenario where you mimic something that happens in the industry all the time. You do some work, next year, the next class or a class in a different country can start where you stopped and have a bigger piece of work to show to a teacher. And the teacher will still be able to evaluate you fairly because there would be a clear distinction from where someone stopped and pieces of work that were added in between and what new paths were explored. And this could be done in such a way that, for example, a lot of tedious school assignments become modular pieces of maintainable work, where everyone that worked in the project had the chance to learn important skills on maintainability outside of the scope of the initial school assignment. This is key and is the sort of craftsmanship that you bring with you to any project once you're working in the industry and you're developing yourself. So why not start early? The worst case scenario, you and your colleagues, for example, finish some piece of work. Yes, it's maintainable, but you reach the conclusion that the work was garbage. Instead of getting graded excellent, you get maybe a good or a decent grade. Trust me, this is still far better than most real life scenarios. Even in many companies that you might be now dreaming of working with, a lot of times the reality in the industry is you have to deal with garbage projects, solving dumb problems, and everything is wrapped around an unmaintainable mess. Think of it this way. Some of the most used and also respected pieces of software out there come from the open source community. And like when you contribute to open source software, you when you work with a maintainability is key and a quality from the start approach, you're setting the bar not for yourself, but for, in your case, for the next year student and the students around the world. Wrapping up, an advice I'd give any student outside of all these advice I've given is to seek actual live communities of stuff that you love, be it a programming language or software testing or something different. Try to find communities that will nurture your growth, that will allow you to connect with people, share ideas, and maybe try to deliver a talk at a meetup. Why not? A personal example, I was a member of the most important testing community in Porto when I lived in Portugal. And through it, I was able to develop myself as a tester in ways I'd never be able to do so by myself. There are tons of communities out there. These are just a few that exist, for example, in Porto and in Portugal. But from wherever you're watching this, there is bound to be a community that in different ways connects with your interests. So go ahead and try to be a part of it. Go explore. Now, we've reached the ending of this video. Thank you for watching. Any questions and comments, feel free to write them here on YouTube or reach me through my social media. Until next time, thank you again for watching. Take care.